Hello viewers, welcome to another class of Gyanon powered by Wishbag. In this segment of Modulation Index with Linear and Overmodulation, we are going to discuss about the topic. Before we delve right into the topic, let us first see that why modulation index is needed. To determine the strength and quality of the modulated signal, modulation index is utilized. If the modulation index is small, then the amount of variation in the carrier amplitude is small. Hence, the signal will not be strong and clear enough and may contain noise or distortions. The greater the degree of modulation, the stronger and clearer will be the audio signal during reception. A carrier wave, after being modulated, the modulation strength is calculated. This mathematical calculation is called as modulation index or modulation depth. It states the level of modulation that a carrier wave undergoes. Let us first look at the definition of modulation index. Modulation index can be determined as the ratio of amplitudes of modulating wave to the amplitude of carrier wave. Mathematically, it can be expressed as M is equal to EM by EC, where M is the modulation index, which is a dimensionless quantity. EM is the amplitude of modulating wave. EC is the amplitude of carrier wave. Modulation index expressed as percentage is called the percentage modulation. Mathematically, we can denote it as percent modulation is equal to EM by EC into 100. Now let us look at the relationship between EM and EC. When EM is less than equal to EC, the M, that is, the modulation index, has the values between 0 and 1, which does not occur any distortion in the AM wave. However, if EM is greater than EC, then this leads to distortion of the signal. Now, depending on the values of percent modulation, AM wave is classified into two categories: linear modulation and overmodulation. Linear modulation. If M is less than equal to 1, or if percentage of modulation is less than or equal to 100%, then this type of modulation is called linear amplitude modulation, as you can see here. Overmodulation. If M is greater than 1, or if percent of modulation is greater than 100%, then this type of modulation is called overmodulation. Now, since M is greater than 1, the envelope can reverse the phase, as you can see here. Hence, this leads to distortion and should be actively avoided. With this, we have come to the end of this session. Let us take a quick look on the topics we have come across in this class. Need of modulation index, mathematical expression of modulation index, linear modulation, overmodulation. So viewers, that's all for this video, and we will meet again on another class where we will discuss a new topic. Till then, keep learning and keep watching Gyanon classes. Bye.